So now we're doing volume of spheres. So volume of spheres is our lesson 7. And the volume of spheres related to the volume of a cylinder that has the same radius and height equal to the diameter of that sphere. The sphere's volume is 2/3 of the volume of the cylinder. To see how you can derive the formula, you can watch that video. So there's a link there. I'll also post these links for this one and the one mentioned in last lesson. I'll post them in our classroom so they're easier to kind of access. In class, we'll probably watch it live all together. But for you at home, if you're doing this lesson on your own, you probably need to watch it on your own. Okay, so if we take a cylinder and a sphere that has the same height and radius, the volume of a sphere would be 4. Oh, I went right to the pi. Must be hungry. It will be 4 pi r cubed divided by 3. So you basically can see that it's 2/3 the volume of a cylinder with the same radius. We can use this formula. Formula is on your formula sheet. So you can use this to help you find the volume of the sphere. Obviously, if you have half a sphere, you've got to adjust. You would multiply that by 1/2, that sort of thing. So let's use this formula and see what happens. So calculate the volume of each sphere to the nearest tenth. So we'll start with the first one. We have our radius. Our radius equals 7 inches. So our formula for volume is volume is equal to 4 pi r cubed divided by 3. So we're going to substitute in that 7, 4 pi 7 cubed divided by 3. Most of you have calculators. You can do this all in one step. When you multiply through, you get 1436.8, because it's the nearest tenth, inches cubed to the nearest tenth. Okay, so it's just a matter of substituting into that formula and remembering what that formula is. Okay, if you're given the diameter, however, like you are with the second one, is you need to find your radius. So the radius will be the diameter over 2. So 21.6 divided by 2. So our radius will be 10.8 centimeters. And that's what we'll use when we substitute in the formula. So volume is 4 pi r cubed divided by 3. And if you don't know how to use the cube button on your calculator, just multiply that 3 times. So 10.8 times 10.8 times 10.8. But you probably have a button for cube on your calculator. So 4 pi 10.8 cubed all over 3. Put that in your calculator. You'll get 5276.7 centimeters cubed. And that's to the nearest tenth. Here, last one, it's a sphere with a diameter of 2 meters. So if the diameter is 2 meters, the radius is the diameter divided by 2. So it's 2 divided by 2, which equals 1. Okay, so our volume is 4 pi r cubed all over 3. So that will be 4 pi 1 cubed over 3. And when we multiply that through, we get 4.2 meters cubed. And again, your calculator can probably do all that work for you. Some of you might want to do the top and then divide by 3 after. Either way, you'll get to that answer. Now here it says, find the volume of plastic to the nearest cubic inch needed for this hollow toy component. The outer hemisphere diameter is 5.0 inches and the inner hemisphere diameter is 4.0 inches. So what we have to figure out is we have to figure out the outer and the inner hemisphere, and then we need to subtract because if we take the outer, we find the volume of the outer, and then we carve out the inner. So we're removing that inner shell. Okay? So we know our diameters. So our diameters for our outer diameter is 5.0 inches. So that means our radius is diameter divided by 2, so it would be 2.5 inches. I just took that 5 and divided it by 2. For my inner, my diameter is 4.0 inches, so the radius is diameter over 2, which is equal to 2.0 inches. And up here it looks like I have inches, so we're going to make sure that says as an N. Okay, so I have my two diameters, that's the hard part, and then I just have to substitute it in. Now remember, it's a hemisphere, right? A hemisphere is half a sphere. Hemi means half. So when we use our formula, we're going to divide by 2. So for the top one, volume is equal to 4 pi r cubed over 3. And then we're going to, once we get this number, we're going to divide it by 2. So I'm going to put in my numbers. I'm going to get 4 pi 2.5 cubed over 3 divided by 2. When I put that all in, I get 32.7249 ... inches cubed. Now my inner hemisphere volume is 4 pi. Now instead of 2.5, I have 2 inches cubed all over 3. I'm putting it in brackets and then I'm dividing by 2. And when I figure this out, I get 16.75516 ... inches cubed. So remember I said we have to subtract. We got to take the outer minus the inner. So that will be 32.7249 minus 16.75516, etc. And I get for my answer 16.755. And it says to the nearest cubic inch. So take a look at that. That's going to help us round it. So we round it up to the nearest inch. So it will be 17 inches cubed. Okay? So you really just have to think about what's going on, scooping it out. Can I find the outer volume of that hemisphere? Yes, I can. Can I find the inner volume of that hemisphere? Yes, I can. So I'm going to scoop it out by subtracting. Okay, so if you can find all the pieces, you can find the answer. Okay, let's take a look here. So our next page deals with golf balls. Isn't that exciting? So golf balls are stacked 3 high in a rectangular prism package. So we can see that. Around the golf ball, there's quite a bit of air, right? Now, within this, it says the diameter of one golf ball is, I'm going to actually make that red so we can see it more clearly. If we take the diameter of this golf ball, the diameter is 4.3 centimeters. Okay? And it says we've got 3 stacked high, so that means we've got 3 diameters going up, correct? Yes, we do. So each of those is going to be 4.3. So that means that that whole height is going to be 3 times 4.3. So 3 times 4.3 is 12.9. So the height is 12.9 centimeters. So we know a little bit of information there about our package. If they're snug in there, that means this is 4.3 and this is 4.3. Okay, I'm just labeling this so we get all the information that we can about this package. So it says, what is the minimum amount of material needed to make the box? So if we're talking about the box, the material to make the box, we want the surface area of the prism. Okay, so our surface area, well, I have 4 rectangular sides that are 12.9 by 4.3. Okay, and I have 2 smaller sides that are 4.3 by 4.3. Okay, so for the 4 here, it's 4 times length times width. So 4 times 4.3 times 12.9. Right? Which equals, let me figure that out. 4 times 4.3 times 12.9. So I get 221.88. And this is area, and it's centimeters, so it's centimeters squared. So this is one piece. Those are the 4 sides, right? And then for this piece, it's 2 times 4.3 times 4.3. Because it's the length times width. 2 times 4.3 times 4.3, which is 36.98. Right. Centimeters squared. I add them together. So the total equals these 2 added together, which is 258.86 centimeters squared. So that's my total surface area. Okay, so because it's surface area, it's centimeters squared, right? Okay, now it wants to know for the next question, what is the volume of empty space in the box of golf balls to the nearest hundredth? So I've got the volume that the box takes up, and I have the volume that the golf balls take up. The difference between them is the air. So the empty space is equal to the volume of the prism minus the volume of the golf balls. Okay, now the volume of the prism, well, I love my rectangular prisms, is length times width times height. And the volume of the golf balls, well, I have 3 of them, but each golf ball is wrote the wrong thing. I jumped ahead. 4 pi r cubed over 3. Now, I can, before I even multiply, divide out those 3's. So now let's substitute in what we know. We also need to figure out our radius. Our radius is diameter over 2, so 4.3 divided by 2. So our radius will equal 2.15 centimeters. We need that number. So here, going back to our equation, our length is 4.3, our width is 4.3, and our height is 12.9. And then we subtract, we have 4 pi, and its r is 2.15 cubed. Okay, I'm going to get 238.521 centimeters cubed, because it's volume, minus 124.8893 centimeters cubed. So my final answer is I have to subtract those 2, and I'll get 113.63 centimeters cubed. And it says to the nearest hundredth, so that's a good answer for me. Okay, so it's just a little bit of figuring out what's going on. You do have to do some problem solving and that things. The individual parts aren't hard. It's just figuring that out, okay? Now, a dozen golf balls are sold in a rectangular box. Each has a diameter of 4 centimeters, each ball. Determine the volume of empty space in the box of golf balls. Now, this will be a good time for you to try this one on your own, thinking about what happens. So remember that the volume empty is equal to the volume of the prism minus the volume of the golf balls. These are different size golf balls, so you need to make sure that you're calculating correctly. These golf balls have diameters of 4 centimeters. Okay, there's 4 across this way, so 4 times 4 is 16 centimeters. There are 3 this way. 4 times 3 is 12 centimeters. And obviously there's just 1 this way, so that's 4 centimeters. So now you have all your measurements. I would pause the video, figure it out, come back and see if you're right. Oh, good, you're back. Okay. I also want to figure out my radius. My radius is actually 4 divided by 2, which is 2 centimeters. So I'm going to need that for my volume of my golf balls. So here, volume of your prism is length times width times height. Yay. Volume of the golf balls, well, I have 12 of them. So 12 times, and remember our formula for volume of a sphere, it's 4 pi r cubed over 3. Okay, now before we even do this, I can divide out. 12 divided by 3 is 4. Okay, so I might as well do that to make sure that I account for that, right? Do that little division there. So length times width times height. Length is 4, width 12, height 16. Doesn't matter what order we do them. Here we'll have 4 times 4, or 4 times 4 pi. Our radius is 2, so 2 cubed. I wrote it squared there. I'm going to just tidy that up a bit. And I'm going to make it a little bigger. So let's multiply. 4 times 12 times 16 equals 768 centimeters cubed, because it's volume. And then 4 times 4 times 2 cubed is 402.1238 centimeters cubed. Now we can do this one to the nearest hundredths. So we're going to subtract these two, and we're going to get 365.88 centimeters cubed. So this is the volume empty. That's how much air is in that package. Okay, quite a bit. Alrighty, now you have practice to do. So it's practicing. Think about whether it's the whole sphere. Think about whether it's one that you've scooped out. Use these examples to help you solve them. Okay, and if you need to go back and look at each